Hey everyone, and welcome back to our trigonometry series for 5.3 mathematics. This video is actually going to be a quick introduction to graphs of trigonometry functions. Okay, the trig functions as a graph. So our ratios, there's an equal sign, they become equations, which means we can graph them. And there are functions. Okay, now it is incredibly related to the unit circle, so we are going to get stuck in terms of the unit circle. But trig functions happen in all sorts of areas. Looking at tides on the beach, as mentioned there, looking at sound waves, all sorts of places our trig functions happen. Now, a couple of things about trig functions and their graphs. They have these little features. One of them is called an amplitude. So the amplitude is how it's affected on the x-axis. So it's the maximum, and the word we use is displacement. So the change in position is displacement. All right, of the graph from a reference level. Okay, and is usually the x-axis, and the reference level is the x-axis, but it talks about how high the wave goes away from the x-axis and how low it goes away from the x-axis. So it's the height or the depth of the wave. Okay, that's the amplitude, the height or depth of the wave. The period is the other feature that we're going to be looking at or talking about in terms of this particular video. The period is how long it takes to complete a cycle. All right, so, or how many degrees we use to complete a cycle. So it is how many degrees it takes to complete a cycle. So in terms of going from 0 all the way through its full wave and back up to 0 again, that's its full cycle. Usually it will be, if it's a straight up sine or cosine graph, usually it's 360 degrees, but that can change depending on the type of values you plug in. So you can have a shorter one where it's only 180 degrees or even 90 degrees, or it could be longer where it could be like 300, so more than 360 could be like 720 or something like that. But the period is how many degrees it takes to complete the cycle, so how stretchy our graph is, and our amplitude is how high or how low the wave travels. Okay. Now, how do we draw these? So we look at our unit circle. Okay. So here I have a little graph, all ones, and poorly drawn circle for our unit circle there. It's pretty poorly drawn, but it does the trick. Now, in terms of the unit circle, we can say that any point on that circle, any coordinate point on that circle, is actually going to have the coordinates of cos theta. So that's our x-axis, or sine theta, which will be our y-axis. Okay, so the y values are the sine thetas and the x values are your cos thetas. And theta is the angle made with that positive x-axis. So if I've got this little section here, when I talk about theta, I'm talking about this angle here. Okay, I'm not talking about the other bit, I'm just talking about where it goes from the x and back around. Okay, so now this is going to be coming from all sorts of sizes of graphs. Now, some things to think about to draw sine and cosine graphs. You do need to reference, might use a better pen there. Reference your unit circle, because it does come back to the unit circle quite often, and it will give you a bit of a hand. Know the amplitude, and know your period. Okay, and you can use a table of values for this if you really want to. And it might even help when you first start out. Okay, let's have a look and actually draw a couple of graphs. All right, so let's do sine first. You'll see there I've actually marked out 4 little spots. So I'm going to give this 90, 180, 270, and 360. Now you'll notice that that relates to our unit circle. We have 0, we have 90, 180, 270, 360. And where our line goes, or our curve is going to be related to where those marks are on the unit circle. Okay. The first thing that we're going to need to look at is when theta equals 0. So one of the things I'm just going to add to my little graph here, theta is going to be along the end, and then y equals sine of theta. It's going to be a little bit confusing at first because this is a brand new idea. So let's have a look at it a little bit more in depth, or a little bit closer, maybe not in depth, but just a little bit closer. So if I want theta equals 0, and I look at my unit circle, when theta equals 0, y will also equal 0. So sine theta will also equal 0. So I can put a dot right here for 0. Now I'm going to add in some y values here. Based on my unit circle, I'm going to go 1, and I'm going to go -1. I'm going to do the same thing over on this one over here, just to be ready. 1 and -1, that's going to be my amplitude, 1 to -1. It matches my unit circle perfectly. When theta equals 0, sine theta also equals 0. When theta equals 90, let's have a look. When theta equals 90, y, or sine theta, equals 1. So I'm going to put the 1 up here. That dot. 180, well, that's back to 0 again. 270 comes down to -1. 360 is back up to 0. Now, I can do a couple of little things here. I can actually draw just a straight line. Bang, 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 bang. But that's not really what I want. That's going to be a completely different function altogether. I want a curvy line. So this is where exact values might come in handy. So if we use the exact value for sine 30, well, that's a half. So I know that I can put in about a third, and then about halfway, an extra little dot there. Okay, and that's going to give you an idea of what's going on. But this needs to be a nice smooth curve. So it's going to come up and around. So that should be the top of the hill, back down, bottom of the valley, and back up again. Okay, so that's what it should look like, a nice smooth line, but not straight. Not straight. And we're going to do the same thing with cosine. Now remember, with cosine, it complements sine. It complements sine. Now before we go on to cosine, just have a quick look at our sine ratio. It does, or our sine graph here, it starts at 0, ends in 0. That is the period. So that is actually the circle of the unit circle. So if I sent my point from 0 all the way around to 360, this is what it looks like as a graph. And that can go again, that pattern can repeat again for the next 360 lot of degrees. It can repeat backwards as well. And it can just keep going, just like sound waves. Now, because it complements sine, cosine will be the other half. So let's pop in our numbers again. Okay, and you'll notice that it starts at 0 for this one. So remember, it complements, so that means it has to add to 90 degrees. So 0 plus 90, well, that's going to make it start at 1. We're actually going to start at 1 this time. Okay, and you can see there that if we've got that on the cos thing, when theta equals 0 for the y value, the x value is going to be 1. So it does actually fit quite nicely. And then we're going to come through, we're going to be at 0, at -1, back to 0, back up to 1. Alright, so you can see that it's just moved over that one lot of 90 degrees. Okay, and same idea, we want it to be nice and curvy until we get there. So this one only looks like half of the cycle, but it is a full cycle for cosine. Remembering that it does complement sine. Okay, let's look at some examples. Look at this one. Use this graph of cos theta. This is a much better example of cos theta than the one I just drew. But we want to estimate the value of cos theta for theta equals 200. Alright, so if we have a look at our graph here, the 200 is going to be roughly here. Okay, that's going to be roughly 200. We bring it down to the graph. That's where it meets the graph. So we come across until we meet the axis, and I reckon that spot there is around about -0.9. So I'm going to say for A that cos theta is approximately equal to, so we use our squiggly equals, approximately equal to -0.9, because it is an estimate. Let's have a look at the next one. For which two values, or which two values for theta can cos theta equal 0.7? So I'm going to go find 0.7, which is going to be roughly about here. If you can see that, I might use a better color. Let's use the orange. And I can come across and I can see that it hits there. I can bring that down. And I can keep going across to find the next value. It's going to be here. Bring that down. And I reckon we're probably looking at around about, or it's not quite 45, so I reckon that's probably going to be 46. And then this one here, oh, well, that might be around about 315 or 314. So for B, theta can be approximately equal to 46 degrees or 315 degrees. It's an approximate, it's an estimate based off this graph. It's not going to be exact. We can do that by doing some algebra, which we're not going to do in this video. Last example here, use the graph of sine y equals sine theta to state whether or not the following are true or false. Let's pop in our unit circle so that we can double check things. Maybe try and do a better drawn unit circle than what I'm going to do. There's my poorly drawn unit circle. Alright, so let's draw in our graph. There's my 1. There's my -1. I know for sine theta I'm going to look like this. Now pop it in. Alright, there's my y equals sine theta graph. That is the estimate. Alright, so sine of 70 degrees. Alright, so 70 degrees, that's going to be roughly here. Okay. Is it less than sine 130? Well, let's have a look. This is 90. This is 180. 270 and 360. Alright, 70 is going to be, what about here-ish? I reckon 70 is going to be about here. I'm going to put up there. Alright, there's 70 degrees. And its height's around about here. If I go to 200 or 130 degrees, which is going to be out here someplace, and I go to my trusty graph, I'm probably going to be about here. But you can see that it's actually lower. Alright, so for 70 degrees is actually greater than, on our sine graph, 130. So we can say this one is false. Alright, sine of 70 degrees is greater than 130, sine of 130 degrees in fact. Let's look at the next one, sine of 195. Well, 195, where's that? That's going to be about here. Okay, let's find that on our graph. It's going to be just after the 180. So it's going to hit down here. And then our other one is 335. 335 is going to be out here somewhere. So we find that on our graph, and it's roughly here. And we pop that on. Might be a bit different there. I might have it in a slightly wrong spot. Let's try that again. Get rid of those. I actually think it's going to be a little bit closer down here. Got it in the wrong spot there. There we go. That's a bit better. And you can see it is actually lower, so this one is going to be true. Because 335 is actually lower than 195 on our sine graph. Hopefully this video has given you a little bit of insight into the unit circle. It is not comprehensive by any stretch. It is just an introduction. Good luck with any of your questions, and I'll see you in the next series.